Good evening. Today I'll be interviewing Abigail and Chase on the subject of how soap works. So Abby, is it okay if I call you that?
Yeah, that's fine.
So I understand that you researched how soap works. Is that correct?
Yes, I have been studying soap.
So what exactly is soap?
Soap is a potassium fatty acid that was made through a process called saponification. Saponification is when oils or fats react with an alkali metal at the temperatures of 80 to 100 degrees Celsius.
What does a soap molecule look like?
A soap molecule is a carboxylate head and a hydrocarbon tail attached to its head, so it looks like this.
And when soap is added to water, what happens?
Well, the carboxylate head of the soap molecule is hydrophilic, which basically means that it loves water, so the head of the molecule has no problem interacting with the water molecules. As a matter of fact, they interrupt the hydrogen bonds within the water, replacing some water molecules with soap molecules through an ion-dipole interaction. However, the hydrocarbon tail of the soap molecule is hydrophobic, which basically means that it hates water, so naturally the tail does not interact with the water molecules.
I've also heard about how micelles are formed. Could you explain this, please?
Yes, since the hydrocarbon tails do not like water, they all cluster together and form these negatively charged micelles.
Why are micelles negatively charged?
The carboxylates from the head of the soap molecules are negatively charged, and they form the exterior of the micelles. The carboxylates also act as a protectant for the interior of the micelle, which is made up of the hydrocarbons. Because of the water-loving carboxylates, the water-hating hydrocarbons never come in contact with water.
Alright, and I know when oil and water are mixed together, they separate. So how exactly does soap change that?
Well, you are right about the fact that water and oil normally separate from each other, and that happens because the oil molecules are made up of nonpolar hydrocarbons, and as I have told you, hydrocarbons are hydrophobic, aka they don't like water. When soap is added to the mixture, the soap micelles act sort of like a bridge between the water and oil molecules. This happens because soap is both polar and nonpolar. The hydrocarbon tails are nonpolar and the carboxylate heads are polar. This allows the soap to act as an emulsifier, so it is able to spread one liquid into an immiscible liquid, which is a liquid that is incapable of being mixed with others.
Oh, so when you wash your hands and the dirt is mixed with the oil on your hands, what happens?
First, the emulsifying soap suspends the dirt and oil. Then, the dirt and oil uses the soap micelles as a bridge, like I said before, and becomes part of the interior of the micelles. These micelles are then easily rinsed away with the water.
Cool. I understand that you have a presentation to show us. Would you like to do that now?
Sure. So as you can see, I have 2 cups half full of water, and I dyed them blue so that you can see the water easier. And I'm going to fill each cup, I'm going to put some vegetable oil into each one. Like this. And as you can see, the vegetable oil is separating from the water. Isn't that cool?
Very interesting.
Alright, now that I've added some vegetable oil to each cup, I'm going to put a squirt into this cup, which is going to be cup number 1. Squirt of liquid soap. There we go. Now I'm going to vigorously mix them for 30 seconds. Alright. Now as you can see, they're still settling down, but you can already see the oil and water starting to separate in cup number 2, while cup number 1 is still basically mixed all together. Alright. Now that that's done. Wasn't that cool?
Very interesting. Thank you for that. I have one more question for you before the end of the show.
Mm-hmm.
Did your research relate to the research of Linus Pauling at all?
Oh yes, Linus. Well, I did look into this, and I found that Linus Pauling touched upon hydrogen bonding, but I did not find anything that really caught my attention and related to how soap works.
Okay, well thank you for your time.
Oh, it's no problem. I had fun.
Well, that closes our show for tonight. Have a great evening.